Sorry for the inconvenience. Actually, the system is not working properly. So I'll keep my video off for the live session thing. If anybody is having any doubt, you please unmute yourself or please type your query in the chat box. I'll be happy to answer that. So let's get started with the live session. So our first topic is to talk about rapid synthesis. So rapid synthesis is basically having an aim. This was being introduced by Professor Repe, and the aim was to how we can handle the acetylene. Acetylene is nothing but HC triple bond CH, and we have to handle the acetylene at higher pressures, ranging up to some hundreds to 200 atmosphere. So he was the one who actually designed some special test tube, because if you're working in a chemistry lab and you need to handle such kind of chemicals which can't hold up to this much high pressure, so the glass fields should be in such should be made in such a manner that that should not explode or something. And they designed these test tubes called Repe glasses. So these glasses were having that potential, that capacity to hold this much higher pressure. So we will not go into the full details of what is the synthesis or something like that. We will mainly focus on the assignment problem related questions. So I will be covering up the reactions which have been asked in the assignment mainly. If you have any further doubt, if you want to have more just into the main topic, you have to go back and watch the course instructor lectures. So acetylene, which we are talking about, the main source of acetylene comes from coal. And this acetylene, it's been used to give many other chemicals, or we can say that it can be converted to more chemical feedstock, which involves vinyl alcohol, cyanide, chloride, etc. It can give you some carboxylic acid products, derivatives, some cyclic products also, and also it involves in making polymers and so on and so forth. So here we will take up its reactions, say different reactions with acetylene. If acetylene is made to react with hydrofluoric acid, which is HCl, in presence of catalyst mercury chloride, it will give you vinyl chloride. How? If we go and say like this way, that this is taking up the negative charge, it will become CH positive and negative, and this is already H positive and negative. So negative will take up your proton this way, and the other side, the chloride will attack onto your positive ion, therefore making a vinyl chloride. This is your first reaction. Similarly, we can have acetylene reacting with HCl in presence of catalyst, nickel, POR, where R can be anything, 3, and these 4 are coordinated with nickel, that is, nickel is having coordination number 4. And similarly, it is positive and this is negative, and therefore one side it will take up the hydrogen, other side goes as cyanide. Therefore, it is called as vinyl cyanide. Next, what we have in hand is HC triple bond CH. When it reacts with carbon monoxide, in presence of water and the catalyst are in carbonyl, it will give you a cyclic product having hydroxyl groups. The fourth kind of reaction that we have is acetylene reacting with C double bond O, Me. It will first form this alcohol, which is called as proportional alcohol, which on further hydrogenation in presence of palladium catalyst and hydrogen gas, this will give you OH, and here it will form double bond, and this is called as allylic alcohol. So here we are converting the acetylene into alcohol. Above, the third reaction is a cyclic reaction also, and giving you an alcohol over there. The previous ones we saw the vinylation reactions, and continuing with that, when it reacts with, so fifth reaction is when acetylene reacts with HCHO, which is formaldehyde, and amine in presence of copper carbide, it will give you NR2. That means amine group has been installed over here. Then next reaction we have acetylene reacting with carbon monoxide again in presence of water. Now the catalyst is being changed. It is nickel bromide and copper iodide, the catalytic amount. And here we will get a vinylic carboxylic acid. Whereas in previous reaction when we saw it was reacting with carbon monoxide in water, when the catalyst is changed, the mechanism goes through a different pathway. Therefore, we ended up having this product. And when the catalyst is nickel bromide in presence of copper iodide, it is giving us carboxylic acid over here. Then we have again reaction of acetylene with formaldehyde and now water in presence of copper carbide. Earlier it was, in place of water, it was reacting with amine source. So here it will form OH over here and OH over here, substitution of this protons with the OH group. And this further, if we have this product, So if we have this product and if I am treating it with carbon monoxide, nickel catalyst, and hydrogen, it will give me HO 1,4-butanediol. So in all these kind of reactions we saw, we have used nickel catalyst, mostly nickel and nickel bromide. We have used iron catalyst, FeCO4 5. We have used copper catalyst as copper carbide, etc. So what it is symbolizing that in having such conversions of acetylene into desired products, which are different chemicals, which are required in different fields, there is a role of 3D transition metal. Here we are talking about 3D, or we can have a or any transition metal source, because somewhere we have used a palladium also, right? So 3D, 4D, or 5D, any transition metal over here, it signifies the role of your transition metals in carrying out the conversion of acetylene into different products, which comes into the Reppe chemistry. So in next lecture, this was a part of lecture 1. And in the second lecture, what we got to know about, there are 4 specific type of reactions which come under Reppe chemistry. So we will take up that in consideration. Okay. So we have now 4 specific types of reactions in Reppe chemistry. Whatever I have told you, the 7 certain examples, they will come under specific 4 types. So first type we have is vinylation. Vinylization reaction, where the substrate would be your acetylene, and corresponding to it, if I am giving HCl, it is giving me vinyl chloride. If I am giving HCN, it is giving me vinyl cyanide. If I am giving it carbon monoxide and water in presence of nickel, bromide, and copper iodide, it will give me a carboxylic acid. So whatever the substrates are being formed here, these are the vinyl derivatives. So this particular type is known as vinylization reaction. Now coming to the catalytic ethynylation of aldehydes. So here also we use the same thing. So what we are doing, we will take up this in further examples. Third type of reaction comes with reactions with carbon monoxide. We have seen 2 types of reactions. And fourth type is your cyclic oligomerization. So these are the 4 different types of reactions that come under Reppe synthesis. And then in next lecture, what we understood that coal is basically the source of acetylene, and this coal is a non-renewable source. It is not going to be, once it is gone, it is gone. So that's why we are looking for other alternatives. So nowadays, acetylene is being, sometimes, some ways it is being overlooked by the ethylene, because even though the ethylene source is also coming from natural gas and crude oil, but getting this ethylene is way easier compared to the acetylene. So whatever the reactions we are obtaining from acetylene, we can get it from the ethylene also. So this is just a new development that we are looking for an alternate of the acetylene, because it requires certain glaciers to hold up that pressures and kind of explosive reactions where we can use ethylene also. So now we will take up further, since we are talking about reactor synthesis, we need to understand what are the different types of, we will discuss the four specific types of chemistry reactions in details. So initially, applications of acetylene. Also, it's one of the major application was that it was being used in welding. 1906, because it was found the use of acetylene and the corresponding process was strongest, it was safest, and simplest to be used as a fuel gas. Secondly, it can reaches up to a temperature of 3150 degrees Celsius. It's very, very high temperature when mixed with oxygen. And acetylene, if it is being unused, something which is left out, since it is having a specific gravity of 0.9, which is lesser than air, so it will not do anything because it will go away. So it is safe to use. So this is one such example or application of acetylene which we see in 1906. Now we will take up the specific types, four types of reactions in proper details. So as we were talking about the vinylation reactions, so we will take up the first heading as vinylation or vinylization reactions. So here we have first example, give you a different color. When we have acetylene and we are treating it with methanol in presence of potassium hydroxide, so what is expected to be formed? As I said, this is negative and this is positive charge. This will go to one side and other side would be wherever the negative goes. If, for example, it takes up negative here or the other way around. So yeah, so if it takes up the negative here, it will form as H negative. This will come as H positive. So this negative will attack on your positive side and this negative will go and attack on your proton. So it will form HCH2 double bond C having H and OCH3. So this particular moiety is nothing but your vinyl. So this is the vinyl derivative. Similar reaction, similar kind of thing we can observe when we have from cyanides. That was from methanol. Now we are taking a cyanide. So I have CH triple bond CH plus HCN, which we have seen earlier also. Again, I'm giving the negative charge to one side because this is a, it would be a heterolytic cleavage. One will take up the negative, one will take up the positive. So this is positive, this is negative, and here it will form CH2, double bond C, here one H, and this is cyanide. So this is vinyl cyanide. Similar kind of observation we can see from hydrochloric acid, which is nothing but your HCl. So we have HC, triple bond C, H positive and Cl negative. Again, this would be negative, this would be positive. And here we are in presence of the catalyst. This is also in presence of the catalyst. To speed up the reaction and to have a specific product, we use a catalyst system and it will form a vinyl chloride. Now, then we have, as I said, that there has been more research conducting from getting the same kind of product from ethylene. So in comparison of acetylene, if we are using ethylene, so we have to take CH2 double bond CH2, you're using chlorine gas in presence of oxygen, it will form a similar product which is CH2Cl and water as a side product. So this is your vinyl chloride, which is coming from the ethylene. And earlier when we used CH triple bond CH plus HCl in presence of the catalyst, it was giving CH2 double bond CHCl. So this was coming from your acetylene. So we can get the same product from ethylene also. As we said, that focus was being shifted from acetylene to ethylene because of its easy recovery from natural gas and crude oil. So similar kind of things we can have it from ethylene also. Now next that we will look into another type of vinyl substitution reactions. So here we have, if I, what was the number? Okay, see. Now we have, now instead of any R's, HC and HCl, I am taking this acid group and I'm treating it with acetylene in presence of the catalyst. Again, we know that one will be having R C double bond O. One will take up the H and other will take up the R C double bond O group. So if we are using here the catalyst to thin here, then the reaction tends to proceed under mild conditions. It doesn't require high temperatures or pressures, the mild conditions, and with high degree of selectivity. That means the region at which it is going to attack, if we have different groups, as I will be showing you in the next slide. So what we meant by selectivity. So if I'm taking here instead of R, I'm taking R1 and this acid group, and here instead of this acetylene, I have substituted acetylene with R2 group instead of the H. Now, if I'm using a ruthenium catalyst, the conditions required is just mild temperatures, which is 60 to 80 degrees Celsius. So there could be two possibilities. One, that it is goes like this in positive forms over here, and your negative are this negative attacks onto your this carbon C double bond O R2, and this is having this product. Or the other possibility of having, I'm highlighting it with the red, I will write it with the red. If my negative goes here, then the situation is reversed. Then we will be having C double bond O. Here it will be CH double bond, and here will be R2. So in presence of the ruthenium, our selectivity for the greener product, it's more. So it is regioselective towards this direction and will form 93 to 99 product. So it is called highly regioselective. We are having a specific ruthenium kind of catalyst. I hope this is clear. By we saying that if we have substituted acetylene, there would be two possibilities of having first product or the product A. We have shown the pathway with the green arrow and the red arrow. So the green arrow is giving us more because the charge, whatever it is, stabilized and it is more prominent over here. So that's why we will be getting a major product as the first one. These kind of questions are expected to come in your exam also. Now, the other type of reaction we have is hydrocarboxylation reaction. This is the second type which I mentioned to be with reactions with carbon monoxide, which is the hydrocarboxylation reaction. So if I am having acetylene in presence of carbon monoxide and water, and this is the catalyst where we have mentioned the catalyst to be nickel bromide and copper iodide. It will give us H double bond CH, C double bond O, OH. This is your acrylic acid. This can also be termed as your vinylization because this product is still a vinyl group, but this is specifically known as acrylic acid. So here for having good yield, the catalyst so used, the best catalyst that would be using, it would be carbonyl, cobalt carbonyl groups, nickel carbonyl, and iron CO4, where it is 18 valence electron and 4 to 5 coordination number it is having, so it makes it more reactive and precisely give us the required product. Similarly, using this method, we can have acrylates also through synthesis of acrylates. Using the same method, acrylate is nothing but your CH2 double bond CH COOMe, wherein earlier we were having the acid group over there. So the mechanism for this particular reaction is will define here. Okay, so mechanism I'm doing it with two pen. So Since we've said that we are going to use a nickel carbonyl CO whole 4, and we will be using an HX to form as this will undergo an oxide reaction where it will release the two molecules of carbon monoxide. Since it is in zero oxidation state, it will go to nickel in +2 with two carbonyls, one H here and X here, splitting of the HX bond. Then I think I should do it in the next slide. So if I'm having this nickel CO whole 4 treating with it HX, it will release two carbon monoxide molecules, and under oxidative addition, it goes from nickel 0 to nickel +2, where two CO molecules are still intact. The HX bond is fitted, and now when we introduce the acetylene over here, C111CH, so this H, which is a hydride, it will go and tag onto your carbon group. So it will go as H2C11CH and nickel COX. Now, at this particular step, out of the two CO molecules, one CO molecule will come, and that would be a MC insertion, metal carbon bond insertion. So it will be forming CH2 double bond CH, C double bond O, and ICO CO whole 2 and X. So after that, since we have this kind of moiety now we introduce our alcohol system, ROH, which will attack onto your C double bond O. It will release the CH2 double bond CH, C double bond OR, and this OR is going to attack onto your carbonyl group, and this H will go and attach to your this moiety. So we are reproducing. This is our active catalyst, which is regenerating, and we are getting this kind of product. So the half part of the reactions have been covered. So this video will be stopped in less than 1 minute. So rejoin the same link. Thank you.